Jugglebot needs to change. I don't really know how I feel about saying that sentence, but I think on the whole, the part of me that feels like it's a bad thing, I think recognizes that this is just a very short-term thing. And the rest of me, who can see a little bit more long-term, realizes this is actually a very good thing. I've done a bit of testing over the last week or so, and have learned a lot. It's been a very valuable period of time. A couple of things have happened. The most important is that the legs are just not fast enough. So I realized after a little while that a very useful experiment to run would just be to throw the ball as high as Jugglebot can. Before that, I was spending a lot of time trying to get the timing right to get it to move around and trying to key the relationship between, or map the relationship between the legs moving around and this string getting pulled was a little bit tricky, and I could never quite get it to work. So I've just finished 3.5-ish days of coding, and it's going relatively well, I think. Some parts definitely went a lot faster than I was expecting them to. The first bits I was expecting to take a really long time. Just like getting all of the matrix math working to calculate all of the Bezier curves. I was expecting that to be a little bit tricky in Arduino, but it was actually pretty fine. So that was good. It was a welcome surprise. But the less welcome surprise has been the fact that the bulk of the brain part is a lot more tricky than I was expecting it to be. I think in my last video, I planned for making, I think 5 functions to do the whole thing for just like throwing and catching one ball in a very, very simple pattern. And I am now up to 20 functions so far. Granted, not all of them are really properly necessary, but still, like, and like figuring out how to like feed them into each other is not trivial, I think. But I made a good bit of progress. I think it's coming along quite well, and I can feel that it's close. It feels like I'm ticking off things to do faster than I am putting them on the list. So that's good, I guess. Yeah, it's coming along. I've only got like 8 more things to go on my list. We're getting there. I'm up to 619 lines of code now, and this is by a country mile the most complicated code I've ever written. It's really, I've had to learn some things that I really did not understand very well before, which is good because now I do a little bit, and it means I can make more powerful things. So the throwing seems to work pretty well. It's definitely a lot smoother than it was before. I am very, very happy with how that aspect is going. Something that I've been working on, probably most of what I've been working on for like the last 3 weeks or so for this project, has been to get all of the movement working in a coordinated way so that the legs can move and the string that attaches the hand, well, the string that sort of actuates the hand, adjust the length properly to compensate for the platform moving around. And I've been very anxious to try this out. I've been sort of putting it off a little bit because I'm a little bit afraid that it won't work and I won't know why it won't work. But I think the time has finally come to give that a go. And then if everything's working, which is probably not, but you know, then I should be able to get Jugglebot to throw the ball in exactly the same way that I do, for example, when I'm doing 2 balls in one hand. So the ball will leave from like over here and then come in, follow up an arc, come in over here, and then it can sort of cycle around. Yeah, we will see if that will actually work. Okay, well, it's a new day. I have had some time to sleep on what I was doing yesterday, and I think it'll be a good day. The main sort of task for today is to get the platform to be able to move around and have the hand not move at all, so that the length of the string between the base and the platform changes as the platform moves around, so that the hand itself stays stationary. I'm going to start off with just moving up and down to get the hand to not move at all. And once I can do that, I'm going to try a little bit more complicated movements with going in a circle, and then it should be good. I think I know what the problem was, but regardless, I was getting too caught up in the weeds with that stuff. So I realized that something that would be very useful to do would just be to practice or try throwing the ball as high as I possibly can. And it was at that moment that I realized that the legs are way too slow. Yeah, which is a bit of a problem because there's not a whole lot within this design that I can change. There's no easy fix that I can make. So it's a bit annoying. I've been finding while I've been working on projects like this that every time you have a big enough mistake on something that you have to replace the whole thing, it's a very useful time to realize what other things are going wrong with that you can also change at the same time. So for example, a problem that I've been having from pretty early on with these linear actuator legs is that there are some nuts in the bottom that I've put in to stop it pulling itself apart basically. And those nuts have just been really annoying. They keep tightening themselves up when they shouldn't. And half of them have come loose from all the vibrations anyway, so they're not even doing anything, they're just rattling around. Bloody nuts. Causing me so many problems. Yeah, no good has come from them. They're very annoying. So I'm definitely keen to not have that problem again. Something else that I am potentially going to be able to change is to be able to get rid of the motor that's pulling the hand string. The reason for this is because ultimately the ball is only ever going to move in 6 degrees of freedom, and by having 7 motors, so the 6 motors of all the legs and then the 1 motor for the hand, this is referred to as being overdetermined. And when your system is overdetermined, it can be fine if you carefully design your system so that it is fine, but it tends to just add complexity to things, and complexity is often better avoided. Sometimes it's very nice, it is very cool, but if you can avoid it, it's a good idea to avoid it because it's just annoying. And I was having a lot of trouble before trying to map the relationship of the movement of this string compared to the movement of all the legs, because they have to be tied together pretty well. If the legs move up, then what will happen is if the string stays still and the legs all move up, it's the same thing as me pulling the string down. And this moves up in its rail as well. Yeah, but by having really fast legs, I should be able to entirely remove that problem and just tie the string onto the wood at the very bottom. So it'll just be stuck there. And then by moving the legs around, the string length would be changing, and that would be pulling the hand up. I think that's a lot better. It's a lot cleaner. It's pretty good. But that requires that the legs are fast and strong. I've been doing a little bit of thinking on ways to fix this problem and to make the legs faster. And the first path that I went down was to look at the way that people normally make Stewart platforms when they're doing hobby sort of things, which is normally people use servo motors, and on those servo motors are attached a leg of a fixed length, and the servo motor rotating around from -90 to +90 degrees, that moves the whole platform around. And those are really good. They're good for certain things. These are good for certain things, and those are good for certain things. So the way that I've been doing it now with the linear actuator legs has typically more power. It can push harder and has greater range of motion, so it can move around a lot further. But the other approach has greater speed, which is pretty helpful, and speed it has. It's way, way, way faster. But it is less strong and it has less range of motion typically. After looking into those for a little bit, I catted one up, and I don't know, after catting it, I realized that the reduced range of motion and the power needs, I think, would be too great. I think it wouldn't be strong enough. I'll show you what I mean. So I've got it catted up here. Yeah. So this is what that design looks like, and you can tell it's very different to what it currently looks like. If SolidWorks is going to play nice, I can drag this around and you can sort of see what it would look like as it's moving. It has a bit of a hard time calculating movement sometimes, but yeah, that's what it would look like, which is very weird. I honestly sort of just want to make this just because it would look really weird, even if I don't think Jugglebot would use this. And I guess it would be a useful learning experience as well, but the problem is time with all these things. So we will see if I actually do that or not, but it is very cool. I would have to change some things about how it currently is, because like things like this, obviously collisions are not good, but that's pretty easy to fix. Yeah. But yeah, so I don't think the motor is going to be strong enough to push the way that I want it to push. I ran a little test with this motor here, with just like a long bit sticking off of it. And I was just like seeing how strong it was against me pushing against it. And I don't know, it's strong, but it's not like super strong. You might be wondering why I made this leg design the way that I did at all. Like, why didn't I use the servo arm method from the very beginning? And there's 3 reasons for this. One is because according to my calculations and according to the numbers that I have on these motors and everything involved, I should be able to move these motors 13 times faster than I am currently able to move them. From all of the information about everything involved here online, the bottleneck would seem to be 200,000 steps per second, where a step is just like a little movement of the motor. But what I'm actually getting out is only 15,000, and for some reason that I have no idea of why, I can't get more than 15,000. Part of this limit of 15,000 could be that I'm using the largest step per revolution increment. Like these are set to move 400 steps in 1 revolution. So if I tell it to move 200 steps, it'll move half a revolution. But you can go all the way up 25,600 steps per second. So 1 step is like hardly anything. So yeah, I think that has something to do with it, but that doesn't really answer the question for me. Like, I don't know what the physical actual limit is. Like, it might be related to that, but I don't know. Doesn't really matter. I am just gonna continue on knowing that it's there now. But according to my calculations and everything, they should have been able to move 13 times faster, which would be fast enough. Like, that's pretty good. Another thing is that this system is very, very strong. It can output a lot of force, which is pretty good for this. I was thinking that if I had a clever way of routing the string in here, then I would be able to massively amplify that force and get a lot of motion and throw the ball very far using that force. And to be honest, I think that might still work, but the legs are slow enough that I don't think they're going to be able to just physically move side to side fast enough. I think it will be able to throw high enough if I put some more effort into this, but there's a fundamental limit there of how slowly it can move side to side, and it's too slow for these. Another thing that was a little bit more important than I think it probably ought to have been is that the control of this sort of platform is a lot easier than with the Servo Arm one. I spent some time when I was designing this like a year ago to figure out the Servo Arm approach, and I couldn't really wrap my head around it, and I never got any of the code to work, so I just sort of gave up and I was like, well, stuff it. I'm probably going to do this one anyway. Like, I'm leaning towards doing these sorts of linear actuators anyway, so I'll just do these anyway that way because I know how to control them and it's super easy. As it happens, I don't really know what I was screwing up before. I guess I've learned a lot more than I realized over the last year, but I had a go at it the other morning, like on the train, and had code that worked. Like, it was not too tricky. There's still a little bit of stuff that, like, I would have a hard time explaining it, I think, but I have code that works. So there's a big help to someone on GitHub had made Stewart Platform simulators. It's very, very cool if you have Processing, the programming app. It's really cool. I'll put a link in the description. that was a massive help. That saved me a lot of time, and I'm very thankful for the guy that wrote that up. Very good. I'm actually in the process now of designing a custom linear actuator that is hopefully, fingers crossed, both fast and strong. And I think it's going to be pretty cool. I have an idea. This is actually what's printing right now, if you can hear that. I think it's pretty cool, and I am very hopeful that it will work, or some close variant of it will work. And I think it's going to be really good. Other things, though, I have redone the whole hand part. It's very, very similar to what it was before. The main differences are that this pulley at the top here is no longer stepped. It's just like a straight over pulley. So it's just like a one-to-one. So if I move my hand down here holding the string by 5 centimeters, the hand will move by 5 centimeters. Whereas one before was 3-to-1. So I could move 1 centimeter and move that 3 centimeters. Now it's just 1-to-1 because the motor's fast enough. I've also changed the way that the string is routed around at the bottom a little bit. I got rid of one of the pulleys, mostly because it just didn't fit in the design. I could print off smaller pulleys, but honestly, at one point I've just got the string going straight over a metal rod, and it's pretty smooth. Something else that I added in this design that I didn't have in the previous one is these 3 arms that sort of like hold the metal rods, and there's linear bearings in there, and they slide along these rods. And the idea there is it just makes sure that this hand has to stay completely flat the whole time. Because a big problem that I was having a little while ago is that that middle part was tilting and like not sliding nicely. So I did that to fix that. I also did a second solution to that, which was to add an adjusting mechanism so that I can control how long each one of these 3 strings is and get them to be finely tuned to be exactly the same. And the theory is that if they do stretch, they will all stretch at the same rate, so that's not really a problem. And if they are all perfectly evenly long, then when I pull them all, so these are all braided together at the bottom here, when I pull it, if they're all exactly the same length, then the hand will have to go perfectly horizontally. Well, it will stay flat the whole time, which is good. So earlier, I spent a lot of time developing this code that would take in a juggling sequence, or a site swap, as I called it before in an earlier video, and it would take the next value in the sequence, which is the height of the next throw, and then based on the various positions of where it catches and throws, it would figure out what speed it would need to throw the ball at and where it would need to throw the ball from, and then it would figure out what all of the leg lengths are to make that happen over a path that it figures out. And I spent a lot of time on that. It was like a good week or so, and it was very complicated. It was definitely the most complicated code I have ever written, and it didn't work. At least in the tests that I did, it wasn't working as I expected. It was very strange. So it would just bounce around a lot, and the timing seemed to be off with something. It was fundamentally there, and all of the tests that I could do in the Arduino IDE, just having it print out values at different times, it seemed to be working fine, but in the actual robot, it wasn't. And I'm not too sure what the problem was. And because the code is so friggin' complicated, I'm not really too sure where the error could be. Because it's not like a missing a semicolon sort of error where it just crashes. It's working in the sense of it's moving. The robot is doing what it's being told to do, but I have just miscommunicated what I wanted to do via my code. And yeah, I don't know what's going on with that. So that was a bit of a, I don't want to say a waste of time, but I'm not going to be using that code, I think, for anything. But it has made me realize that I need to learn about ROS, or the Robot Operating System, which basically allows you to have various nodes connected to each other, and they can send and receive information between each other. So for example, I might have a node for moving all the legs, and I might have a node for watching the balls with the camera, and I might have a node for being the brain, and these can all just talk with each other. And it's basically this ROS is like an infrastructure for you to put your network into. It's really cool, but it's very hard to learn, and it's very unlike any coding that I've ever done before, and it's very confusing. Yeah, but I'm getting there slowly. It's gonna be very good for this. It is exactly what I need for this. So just gotta be patient and learn it. And something that's kind of nice with that is that it has a simulator thing. I have not learned how to use it yet, but I have no doubts that I will eventually. And in that, you can just simulate the robot, and you can just say, I'm sending these commands to the robot, and the simulation receives them thinking that it's the robot, and it goes. And you don't actually need to do anything on the robot, which is really cool. And this opens up a lot of possibilities for AI control of Jugglebot. Because there's another thing called NVIDIA Issac Sim, where you can put in a model, it's like sort of like a CAD model, into the program, and it's like a physics engine, and you can tell it what you want to do. So for example, I could want it to throw the ball using this, I guess maybe if you can figure out another way to do it, but generally using this thing, and just throw and learn. And I will just tell it nothing. It will just have the ability to control the positions of the 6 motors, and it will just go and figure it out, which is pretty interesting. I think that an AI controlled Jugglebot would do better than the human controlled Jugglebot for sure. It's just a matter of whether I can do it. I'm in a bit of a crossroads right now. I don't know whether I should spend more time on making it controlled by me using like traditional methods versus making it an AI controlled one. Because there's a lot of stuff there's a lot of unknown unknowns for the AI controlled one for me, because I haven't really done AI stuff before. And as I was saying, I haven't done the ROS stuff before. So there's a lot. But the other way, I feel like it feels easier, but you have to, if you're controlling things from like the ground up, you have to be very, very precise. And that's difficult when you're 3D printing things and cutting them with your hands, and there's friction involved everywhere. Yeah, it's tricky. So that's about it for what I've been up to. It's been an interesting learning experience. A lot's going to change. Jugglebot is not going to look like this for much longer, which I think is a good thing moving forward. All right, well, thank you for listening, and I hope you found this interesting. And until the next one, I hope you stay well. See you then.